Okay, here's a lecture on a couple of things for the Intro to Wind Energy class. First off, I want to make sure you've all had a chance to see this website that Cameron shared with us. And it's actually part of a website that I think I brought to your attention early on. I didn't even realize it at first, but you can get to it through Sail, but you can also just type in windpower.org. And remember that org tells you that it's a nonprofit organization. So this is a nonprofit. And when you get there, you get a foreign language. Velkommen. This is Danish, which doesn't help us a whole lot. But over here, there's a link to get the site in English. So if you click on that link, it'll bring up the equivalent page in a language that most of us can understand. And there's a lot of news and information, and they got some pretty cool pictures here about offshore wind power. As I mentioned in class before, we in the United States have virtually no offshore wind power turning as of now. They hope to have some soon, but I'm sure working on those is interesting. So there's lots of great resources here. One of them, if you scroll down, this is the one that Cameron discovered and shared with me, and I passed on to you. This little fella named Miller. And this is really aimed at children, but I'm not ashamed to say that I learned a few things when I went through this. You can get here through the link that I emailed you as well, but see, once again, we have a language that's not English. But let's see. Down here, if you want the page in English, you can click on that word that looks kind of like English. And this is where we get to the Wind with Miller. And there's a whole bunch of different things here. You can also pull this down. Maybe we can start with, how does it work? And here we have a graphic with Miller with a bunch of different things spread out. So we can start with one of these. We can start with the nacelle. Oh, we have to click on this. Forward. Make a windsock. Well, I guess we can do that, but that might not be what we want. This describes the main shaft. It actually gives you a link to an actual main shaft. Of course, this is the connected to the transmission. This would be connected to the rotor, blades, and so forth. And next we have the gearbox. And this gives you a nice graphic view of that. And it gives you a picture of the inside of a gearbox. And of course, the outside of the gearbox. So you have the main shaft out here, which is being turned by the rotor, which is then turning the transmission, which changes that low-speed rotation into high-speed rotation. And then you have a high-speed shaft, which goes from the transmission to the generator. So we can look at an actual small shaft. And the braking system, this is very much like the braking system on your car. but it's a secondary system. The primary system is the blade pitch, and some turbines now have blade tips that can be pitched in order to stop the turbine. And the other important use of this blade, this hydraulic brake is to lock the turbine in place, or to lock the rotor in place while you're working on it, so it doesn't start turning when you don't expect it to. And then this is a description of a generator, and there's a picture of an actual generator. And then the controller. This would be a more elaborate version of the PLCs that we're going to be working on. So I think we got some. So this gives you an idea. This is where all of the information from the sensors is going to be monitored, and the wind direction, wind speed. That information is going to be used to control the operation of the turbine. And then the anemometer. I think most of us have seen a device like this before. Tracks the wind speed, which is important because if the wind is too fast, the turbine could be damaged and you need to stop it. By the same token, if it's too slow, the turbine's not going to be able to generate electricity, and it will also be stopped. And then the wind vane, which provides information about the direction of the wind, so that the turbine can be pointed into the wind and squeeze the most energy out of the wind, or derive the most energy from the wind. The yaw motor. Yaw is the rotation of the turbine on its axis to keep it pointed into the wind. See, we get some actual yaw motor there. Powerful motor with a big old gear on the bottom there that's going to mesh with the gear on the nacelle. And this is going to be the well, they call it a bearing. I guess it is a bearing, but I would think of it as a gear that the yaw motor connects to. So we can look at a real one while we're at it. This one, it looks like the teeth are on the inside. And then there's a cooling system, because the generator and the transmission, for that matter, creates a certain amount of heat that has to be dissipated. So the transmission and the generator will both have some sort of a heat dissipation system, whether it's air cooled or using some kind of a coolant like the radiator in your car. And then the rotor, which is the blades and the hub. So we'll spend some time in class going through and exploring these and see what we can discover. But there's some interesting simulations in here. Well, let's see, again, this is aimed at kids, so they're looking for activities that you can have kids do to get them interested. So there's a lot of depth to this. Let's see, I think I was looking earlier at the Turbine Simulator. Okay, this is a simulator. You pick a turbine. We can go with this 1000 kW, which is 1 megawatt. Down here you can control the wind speed. This small indicator here, you click and drag it to the right just to where the turbine starts to turn. So it looks like this turbine, it says 4, and that's meters per second. So it looks like this turbine is starting to turn at 4 meters per second. Okay, so we have to answer a question here. So you click on the calculator, and we're supposed to say how many meters per second does it take to make this turbine turn? Well, I just told you it's 4, and you can see it down here. So I just enter 4, enter. Yes, that's right. So you can do this for other wind turbines because they don't all have the same. Oops. So let's see. Try the Nordex. So I can drag this one around. Looks like this one's going to start at 4 meters per second as well. How about we try the Vestas? Well, I'm not sure. I'm not sure if that's the plan, but it looks like they all start turning at the same wind speed. The point they're trying to get across here is that there has to be a minimum wind speed for the turbine to work. Then we get into determining how much power the turbine generates. And for some reason they want us to click the cow. All right. So again, we have to pick a turbine. We'll stick with the bonus 1000 kW. So I'm going to move this until we get, and we'll go ahead and leave it at 4 meters per second. All right, so I have to get the calculator. How much power does the wind turbine generate at a wind speed of 9.7 meters per second? So the first thing I have to do is drag this over until it says 9.7. Then I have to come over here and look at, this tells how much power it generates. If you click on it, it actually tells you the value is 407 kW. It's kind of hard to read from that scale. So I'll just type that in, 407, enter. What? The wrong answer? All right, let's try this again. Oh, I see. I have to put this at 9.7. I was at 8.7. Okay, whoops. Ah. Okay, now I can click on this again, and it says 542. So I go to calculator, and I type in, well, I clear that, 5, 5, 4, 2, enter. All right, I think I got something there. Yes, that's right. Okay, so but you can do some interesting things here. One of the things you can do is you can adjust the wind speed, and notice that it reaches a maximum. Well, if you get past 25 meters per second, it stops reading because then it's going to, the turbine is going to stop turning. But how fast does, so the wind reaches, the output reaches the maximum output at 16 meters per second. So any wind beyond that isn't really generating any more electricity, at least not in this turbine. So that's kind of interesting. The next activity has to do with the relationship between how high the turbine is, and the amount of speed that the wind has in it. So we'll play around with this a little bit in class to help you develop a better understanding of uh, how some of these components operate and the part they play in turbine operation. I know some of you have sent me uh, information about that project I put up there. The plan for that is to uh, gradually develop it, work on it a little bit at a time until we have a rather elaborate, each of you has a rather elaborate presentation on wind turbine operation that goes into a great deal of depth and that you can use. Well, the best way to learn something is to explain it to somebody else. So as we go through and we learn about these things, you need to be developing ways to explain and not just copy or repeat things that you've seen or heard. So that's my goal with that, and we'll also talk about that in class a bit. So